Right, welcome back. Okay, so in the last video, we looked at how to work out the empirical formula and then the subsequent molecular formula. And that's all well and good, but sometimes it's not as simple as that. So we need a little bit more detail, and that's what we're going to look at in this video. Okay, so learning targets. You should be able to recite the ideal gas equation and know about the different components which make it up. And you should be able to use this equation to work out the molar mass and subsequently the molecular formula. So hopefully you can remember that to go from the empirical formula to the molecular formula, you need the molar mass. Now sometimes this might just be given to you, but if not, you might have to get that molar mass. Now if you're lucky, they might just give you a mass spectrum, and it's easy to get the molar mass from that. We'll come on to that in a later chapter. But they might not be that kind, and you might have to derive it using the ideal gas equation. So, ideal gas equation. Now this equation is used to get the molar mass when you either have a gas or a volatile liquid. Okay, so let's just go through what the different parts mean. So the P stands for pressure. Now the units we use are pascals. Now just remember that 1 kilopascal is equal to 1000 pascals. This is one way they may trip you up, in that all you have to do is put in numbers into the equation, but you have to make sure they are using the correct unit first. Okay? So V is the volume, but unusually the units are in meters cubed. Not centimeters cubed, not decimeter cubed, which is the normal unit at AS level, meters cubed. So again, you might have to convert this. So as you can see, a meter cubed is a very big volume, bigger than the other two which you've potentially used before. Okay, so make sure you know how to convert between centimeters cubed and decimeters cubed to meters cubed. Now N is the number of moles. R is what we call the gas constant. Now this has a constant value, 8.31 joules per Kelvin per mole. Now this is sometimes given in the question, but sometimes not. So again, it's something you need to memorize. And last but not least, T is temperature in kelvins. Okay, so this is our ideal gas equation. So how can we use this to work out molar mass and therefore subsequently the molecular formula? Well, you need to be given several pieces of information in the question. First thing is the mass. This should be in grams. And you should also be given all of the values from the ideal gas equation apart from the number of moles. Now remember, you might not be given the gas constant, you might have to remember that, and the other components may not be in the correct units. So just be careful with that and make sure you convert them if necessary. Okay, so those are the pieces of information you should be given in the question. So what are your steps for working out the molar mass? So number one is just to rearrange the formula to get the number of moles. Okay. Now you need to be given the mass. You've just worked out the number of moles, and as you should all know, mass divided by number of moles gives you the molar mass. So now that you have the molar mass, you're likely to have worked out the empirical formula earlier in the question, and using those two things, you can then work out the molecular formula, just like we did in the previous video. So now hopefully you should be aware of the ideal gas equation. Remember, you need to learn this off by heart, including all the different components and the units used. and you should be able to use this equation to work out molar mass and subsequently the molecular formula. If you're unsure about how to do any of that, please look through the video and make sure you finished your notes for the next lesson. Alright, I'll see you there.